All right, we're going on now to do something a little extra in terms of topic 5.5, and that is I'm going to spend this whole tape going over what we call the AC method. And we already did a lesson on this where we did this in the traditional sense. That is, putting it in standard form and then guess and check until we got the right combinations. But there is another way. In fact, I was talking to a teacher the other day and she said, this is the only way that she goes. She teaches the AC method. So what is the AC method? Well, some of the things we've done before, for instance, step 1 is to put it in standard form. And standard form is ax squared plus bx plus c. Step 2 is to factor out any common denominator, the least common denominator from all the terms. Then this is where it changes a little bit in that we are going to multiply for step 3 a times c. In fact, that's where we get the name of this method from. Multiplying a times c. And we're going to put that there, so to speak. Then we take that and we want to find factors of that that will equal our b term, which is this term. Then once we do that, we rewrite the expression to include these new factors of b. So in a sense, we go from a 3-termed polynomial to a 4-term polynomial. Now once we get the 4 terms, we're going to use that technique we had earlier, factoring by grouping. And then check our answers, and we're sure if we factored something out to include that in our final answer. So with that in mind, let's start to work on number 1. So we have to identify, it's in standard form, there's no common factors. We're going to multiply the a term by the c term. And 10 times negative 3 gives me a negative 30. Now, here's the sort of challenging part where we have to look at our b term. Remember, our b term is a positive 1. Now, we want factors of a negative 30 that will add up to a positive 1. So as we sort of think of it, do you see that perhaps a 6 and a 5 come into the mix? Factors of a negative 30 that have a positive 1 as their sum. And I see a 6 and a 5 in there. Well, how about a negative 5 plus 6? Now, a negative 5 plus 6, when we multiply it, it gives us our AC, which is a negative 30. But when we add them together, will give us a positive 1, which is what our b term is. Now we rewrite the equation using these 2 new factors for our b term. And it's just 10x squared minus 5x plus 6x minus 3. Now notice, this is actually the same as this, where we would have combined like terms. And you see what we're doing. We're kind of going backwards to something. And now we have a four-termed expression that we're going to factor by grouping. Is there a common factor in these first two terms? And the answer is yes, there's a 5x there. And we're left with 2x minus 1. Now how about these next two terms? Is there a common factor? Yes, a plus 3. And I get 2x minus 1. And now you'll note that we do have a common factor here that I will put here, 2x plus 1. And then I take my 5x plus 3, and there I have successfully factored that using the AC method. Now we're going to do a lot of them, but the key is you need to somewhere jump in and try it yourself to see if in fact you're going to get this technique. But we'll be illustrating the technique as we go along. Now if you were to FOIL this, you see it comes up to what we have. And I see I put the wrong sign in there. Don't want to do that. There you go. Because I wasn't getting a negative 3 when I checked it. Okay. Example 2. Again, is it in standard form? Yes. Is there a least common factor, or greatest common factor, I should say. I want to put the least common factor here. I want that to be the greatest common factor. There you go. That we can factor out of there. And the answer is yes. We could factor out an A. That's correct. So we get 6a squared minus 11a minus 10. Now this next part's pretty easy. We want to define what will the product of AC be, our A term and our C term. A term and C term. Well, that's going to be a negative 60. So we have a negative 60. Now, what we're looking for is factors of a negative 60 that are going to add up to a negative 11. And here you start thinking about what are some factors of 60. Well, the common ones would be 6 and 10. That does it. But when I think 4 times 15, 4 times 15, I see that these factors will add up to an 11 if the 15 is negative and the 4 is positive. So there's my negative 11 right there. Now what I have to do is rewrite this using these factors to replace my negative 11. That will give me 4 terms, because here's 1, here's 2 terms, that will make this 4 terms that I can later factor by grouping. So let's rewrite it. 6a squared plus 4 minus 15a minus 10. And I need to put an a there. There we go. So plus 4 minus 15 gives me my negative 11. But now I want to factor this. And keep in mind that there's an a there as well. Can't forget that a, but we'll leave it there for now. And out of these first two, I'm going to factor out a 2a. So 2a, and I'm left now with 3a plus 2. And these next two terms, I have a little problem, because these are both negative, and I want a positive in my parenthesis here. So to flip the signs, remember our technique of factoring out, in this case, a -5. By factoring out a -5 out of a -15a, I get a positive 3a plus 2. And that's what I'm looking for right there. But I had to factor out the -5 in order to reverse the signs. Now remember, and it might be a good technique to do it this way, put your a that you factored out originally right there. And now what do you get? Well, we're going to get an a, parenthesis, and I can put my 2a minus 5 first. And then I have one of these, 3a plus 2. And that's the factorization of that using the AC method. Now, might you have factored that using the traditional guess and check? And the answer is yes. But this is a fail-proof method. It may take a little longer, but it works every time. Now, what I've done here is to set up sort of a pattern. In this case, this trinomial was in standard form already. This one was not in standard form, but I rewrote it so it would be in standard form. And we're going to try to find AC of each one. And then we want to get factors of something that will equal b, our middle term up here. And we reviewed this already. So let's take a look at number 3. As we look at it, we want to multiply 40 times a -15. That's going to give us a -600. And now we're looking for factors of 600 that will eventually have the difference of 38. So this is a rather challenging one. So I'm going to share with you a technique that I often use when it's difficult to see the factors right off. And that is to start factoring 600 and make that little prime factorization tree. Now I know a 2 will go into there, and that'll give me 300. A 2 will go into there, and that'll give me 150. A 2 will go into there, and that gives me 75. And I know a 3 will go into there, and that'll give me 25. And a 5 and a 5. So along this edge, this goes way back to chapter 1, we talked about making a prime factor tree. It doesn't look like a tree, but this is the way I do it. And those are the prime factors. Now you're looking for combinations of things that when you, in this case, subtract them, they're going to give you a -38. So again, I did this with paper and pencil, and I had to figure out which they were. Well, let's look here. 5 times 5, that's a 25. I'll just use some scrap here a little bit. And then 3, that's 75, so that's no good. So I have to use one of these 2's, let's say. So I'm going to use a 2 and that will give me a 50. And then I have a 2 times 2 is 4, and a 3, I think I have it. That's going to be a 12. So the difference between a 50 and a 12 is 38. I just have to work on the signs. So I'm going to need a negative 50 and a positive 12. So that's what I'm going to put in here. A negative 50 and a positive 12. And this was what I had off to the side to give me some direction. So now what I have to do is rewrite this trinomial and then change this b term to use these 2 terms. So it'll be 40t squared minus 50t plus 12t minus 15. Now I have a 4-termed polynomial that I'm going to factor by grouping. So out of this first one, I can factor out, let's say, a 10. Yep, a 10t out of these 2. And I then get 4t minus 5. And out of these last 2, I'm going to factor out a 3, and I get 4t minus 5. Wow. Again, you're looking for something that you got out of here to get out of there. So you can factor by grouping. And now you end up with 10t plus 3 times 4t minus 5. Back in section 5.1, we talked about multiplying a binomial when we have it set up like so in the traditional way. We would take this, multiply it by that, then we would take this, multiply it by that. That's what we have here. And then we would then distribute and get this, collect like terms and get that. So we are undoing that traditional multiplication we did way back in the beginning of chapter 5. But it's a good technique when A is not a 1. Okay, looking at number 4 now, standard form. I told you I put it in standard form. It wasn't. But now I can see I can factor out a what from each term? A 5. So this gives me 4x squared plus x minus 3. And again, we're practicing this AC method. So let's change colors too a little bit. So our A is 4. Our C is negative 3. That's going to give me a negative 12. And I have a positive 1 for my B term. And it looks like a 4 and a 3 here. And since I need a positive 1, this will be a positive 4 minus 3 will equal our B term, which is a 1. Now we rewrite it. Keep in mind we have the 5 there. And we'll put it maybe in a big parenthesis here. 4x squared plus 4x minus 3x minus 3. So we now have a 4-termed polynomial that we're going to factor by grouping. Keep in mind we need the 5 there. And out of these first 2 terms, I can see I can factor a 4x and get x plus 1. Now, again, this is a negative and this is a negative. In order to get an x plus 1 here, I'm going to have to factor out a negative 3. Change the signs. And then when I rewrite my answer, and I may be out of room, so let's write it 5 times 4x minus 3 times x plus 1. Okay. And again, if we FOIL this, we would get this over here, and if we multiplied it by 5, we would get that. Keep in mind that this 5 is an important part of the answer. You tend, once you factor it out, to forget about it, but it's there, it's an important part. And once again, we're kind of using this pattern. We have the trinomial set up in standard form, and we're going to factor out the greatest common factor if there is one. Then we're going to multiply a times c, and then we're going to take factors of that product that equal b. Okay. So again, if you want to try these, you could write them down, try them on your own, and then watch the tape or continue the tape so you can see if you're getting it. And that's the proof of the pudding, that you're able to do this. So 35, 9, 2, no common factors there, but m to the 5th, m to the 4th, m to the 3rd, we can take out m to the 3rd out of each term. And it never hurts to check your work. And now we're going to multiply a times c, and we're going to get a negative 70. Now we want factors of a negative 70 that are going to give me a positive 9 when we add them together. So again, let's use this technique. 70 divided by 2, that's going to be 35. Divided by 5, that's going to be 7. So now we want, out of these factors, a combination that's going to give us a positive 9. Do you see it yet? Well, 2 times 7 is 14. 14 minus 5 is 9. So that's the factors. So they're going to be a 14 and a 5. Now, what signs? Because one has to be negative. Well, we're going to have to subtract the 5. So 14 minus 5 is 9, our b term. Multiplied together, they give me a negative 70. And again, practice. So now we rewrite this expression here. Remember, we have the m to the 3rd in there. So 35m squared. Now we're going to change this 9 into this. So plus 14m minus 5m minus 2. So we've just changed this from a 3-term expression to a 4-term expression, converting the 9 into factors that, when they're multiplied together, produce a negative 70. But when they're added or subtracted like this, give us the b term. And now we just do it again. M to the third. Here we're going to factor out a 7m. And that's going to give us 5m plus 2. And look, we have a 5m plus 2 there as well. But opposite signs, so what do we need to take out? A -1. So our final answer then is m to the third times these two, and then this. So again, if we were to multiply these traditionally, we would multiply this times this times this. We're working backwards or forward, depending what you're doing. Okay, for number 6, again, it's in standard form. I don't see a common factor. So when I multiply a times c, I get a 60. Now I'm looking for factors of 60 that are going to add up to 16. Well, every once in a while you have an easy one, and this is sort of an easy one. How about 10 times 6? And we're just going to add them together. So 10 times 6 is 60. 10 plus 6 is 16, my b term. That's what I wanted. Now I'm going to rewrite this expression using these factors for b. So I get 4x squared plus 10x plus 6x plus 15. Now I'm going to factor by grouping. Out of these first two terms, I can take a 2. 2x gives me 2x plus 5. And out of these two terms, I can factor out a 3 plus 3, and I get 2x plus 5. Very good. And now I'm using these two in one parenthesis, 2x plus 3, and this in one parenthesis, 2x plus 5. Now if you put this two terms first and this second, that's fine. That's okay, and sometimes you'll see the author does that, and sometimes they'll do it this way as well. So again, this is the AC method. And through practice, hopefully you're going to be mastering this skill. Again, what we're trying to develop here is a protocol for doing these. And I went through part of this because I think you see the pattern. You put it in standard form. Again, we don't like to have a negative in our initial thing. And also we see we have a 2. We can factor out of each term. So that's what I did here. And then I multiplied 9 times 5. And let's see if I get the right signs here. Number 7. Well, this is a -5 when I took that out there. Okay, that's better. So I get a -45. Now, I worked ahead and I said, I need a -12 for my b term. So what are factors of a -45 that give me a -12? Well, a -15 and a +3. Now again, I had to spend time working that to figure it out. And then now I'm going to rewrite this 3-term expression into a 4-term expression using this as my b term. So again, I need to include the -2, and this will be 9z squared minus 15z plus 3z minus 5. Then I'm going to factor it by grouping. And out of here, you can see I can take a 3z out of there. And I get a z minus, let me see, how about a 3z here? Minus 5. And notice I have a 3z minus 5 there, but I need to factor out of that a 1. You could factor a 1 out of anything. And then my final answer will be -2, and then these two, and then this. And we can check that there. And I gotta be careful about putting that negative sign in there, yes. Okay, so this was a negative and this was a -2. All right, for number 8, this was sort of backwards, and this term was a negative, so I took out a -1, put it in standard form. So that's where I'm going with it. So I'm multiplying my A term times my C term and getting a -300. And I'm looking for a B term of a +20. So my factors of a -300, and again, this is after I worked it for a while. 30 minus 10, yeah, that's a +20. So now I'm going to rewrite it. Again, I have a -1 out here. And I have here a 25x squared plus 30x minus 10x minus 12. I guess I could use a parenthesis there instead of a bracket. Now I'll use a bracket. -1. Now out of these first two terms, I'm going to factor out a 5x. So 5x gives me 5x plus 6. And then out here, we're going to factor out a -2. 5x plus 6. And then my equation will be a -1, this, 5x, or my expression, and then this. And let me check, I think that is correct. For number 8, yes. Okay. And to keep the tapes a little bit shorter, for number 9, I have a to the third b, a to the second b, ab. So the common factor that I can factor out is ab, and then I get it in standard form. And then when I multiply 8, my A term, times a -15, my C term, in this AC method, I get a -120. And I'm looking for a B value of -2. Well, a negative 12 times a positive 10. Now keep in mind, here it's appearing very quickly, but I sat down and worked at it. It didn't just pop up. I had to work it to figure out. And then I rewrote this, so my b term now is in this new form, where it's now 4 terms that I'm going to factor by grouping. Here I'm factoring out a 4a out of these 2 terms, and I get this. And then out of the last 2 terms, I'm going to factor out a 5, and I get that again, which I write here, write this and this here, and don't forget I need my AB. Now for number 13, notice I didn't fill in anything. And again, this is sort of like a form, a modus operandi for setting it up, but here A is not a 1, but A happens to be a perfect square. And this happens to be a perfect square. And if I take the square root of 25, I get 5. The square root of 4, I get 2. 2 times 5 is 10. And if I double it, I get this. So this is something we're going to work on in topic 5.6, where we have special products. This is a perfect square trinomial. And perfect square trinomials, you may recall, factor into a binomial squared. And this is a technique we're going to work on in the future. So you have to keep that in mind, because sometimes when a student sees this, they kind of freeze up. And it would be the square root of that, which would be 5c. The square root of that, which would be 2d. And whatever the middle sign is there, that's what goes in the middle. So if you multiply this binomial using that special technique, square this term, multiply these 2 terms together and double it, square this term, and that's the answer. Okay, well, here are some instructions on multiplying using the AC method, or I should say factoring trinomials using the AC method, and hopefully it's helpful to you. You need to practice it, though, to master it.